Hi, I'm Printed for Fun, and in this video I will show you my process of post-processing a scan within Revo Metro, so the software for the Revopoint MetroY Pro. I scanned a festive Christmas ornament for the current Christmas themed scanning performance of Revopoint, or scanning competition, I would call it. Yeah, it's like a wooden deer with nice lights on it. I did 2 scans of it, so like side 1 and side 2. The scanning was like done in a very simple fashion. I placed, like, you can see the outlines of they are like very black business cards with markers glued on them. And I also used marker geometries. You can see them here a bit, just to allow like lower scanning angles. So I already did the fusion step. So for the people like new in 3D scanning, the normal steps you do for post-processing are you perform the scan itself, then you have raw data. You can see it here. It's like you have floating points, you have a very rough surface initially. Then you do the fusion step. I already did it, so you can see there is already fusion, a fused model. I actually did batch processing for both of them. So normally you have do the fusion for one model, but you can also select the batch processing and then simply check the models you want to fuse. So that's very nifty. For fusion, I selected high quality fusion with the recommended settings. That's quite nice. Like in a recent software update of Revo Metro, they added this defaults button, I would say it, and it automatically adjusts to the scan settings. Or like, it's not like actually the scan setting you've chosen, it adjusts to the actual capture data quality. So I've scanned quite a lot in this model, so I could select like the 0.2 millimeter setting, so that's quite nice. In the next step, after fusion, you normally align models. So I have 2 sides of the model and want to align them into one model. Then I isolate floating points. I delete overlaps, like if I align the scans and the light strip changed moved by 0.2 millimeters, it deletes like this duplicated data, and then I can mesh the final model. But let's first start with cleaning up the single scans a bit, and then we can go on with the meshing. To make the cleanup easier, I will switch to orthogonal view. So currently we are in the perspective view, but I will switch now to orthogonal view. So I do this so I can simply like orient the model like this, select the polygon tool, and just delete all the data I'm not needing. You can also see I'm using my space mouse. This makes it very easy for scanning. But the space mouse in the orthogonal view only allows rotation, not like full free movement. So next step, I will also select these floating, sorry, I selected a bit too much. Okay, I just use the del key or the escape key to now remove all the selection, and I can just redraw it. Okay, well, here we have some data. Here we go. So this is like very straightforward. There is also the option to select a connected domain. Connected domain is basically you brush part of the model you want to keep, and then use connected domain, and it like automatically selects all data that is from the same object. But for this kind of woven wood fabric, I'm not too confident that all parts are actually connected. It could well be that some of the wood strands aren't connected. so I won't use this feature since it will most likely accidentally delete some data I don't want to delete. Now we are already in the second scan, and I will basically do the same steps. So it's like just go around the model for the selection. Here we have one small geometry, and here in the top are a few more. You could also only scan with the like these marker plates or marker cards I've been using, but using proper geometry, they're like half domes with markers on it, makes it a lot easier for scanning to the sides. So without the marker geometries, I very well couldn't have scanned here, laying it down like this, scanned these parts. So I was nearly horizontal to the table I placed it on. So in the next step, we will align the models. It is called merged in the RevoScan software, and we will use the feature alignment. So you could also manually align the scans by simply picking common points. So yeah, okay, I have like this point on the tail, and on the other scan it's this point, but I don't need it. There should be enough overlap to just use automatic alignment, and so a rough rule of thumb is at roughly maybe 25% of overlap, the alignment is like nearly always succeeds. If you're scanning especially flat parts or like body panels without much features, you could also create artificial structures or artificial features. I also have some blue tack in my scanning bag or scanning pellet case I can use to create like small bubbles or dots on the surface, which I can later use for alignment. And as you can see, it looks quite great, I must say, the alignment. So we can generate a model. And what I quite like here in RevoScan, or Revo Metro it is now called, is that the alignment process generates me a completely new model within the RevoScan software. So you will now have to wait a few seconds, and you also can see the overlap between two scans. That's quite nice. Maybe I will like redo the alignment right now to capture a small screenshot of the alignment to show how well it aligns. Because I wasn't sure how good the object behaves with these small moving wooden strips, I would call them. But it did great. So it still takes a few seconds. You can maybe also have a quick look at the task manager, how much resources it consumes, but I'm currently at 18 gigabytes of RAM used, and it looks like it aligned good. So I can now go to, I will just redo the alignment and capture a screenshot of it. So here we can see how well it aligns. So this works for me. So next step is after creating the complete model, as you can see here, I will rename it to simply deer, and we can do the overlap detection. Overlap detection basically isolates small moving parts or small free-floating parts. It could be for this kind of model that the overlap detection accidentally selects too much data, like seen here. I will maybe reduce the isolation rate a bit. So the lower the percent rating you're selecting, the smaller the parts you isolate are. So let's try it out. Okay, this is good. So we can click apply, and it deletes all the overlap data. And I will also like delete this cable here in the back since it moved between the scans, and there is like no good use to it. So I will now switch back to perspective view so to have full control with my space mouse. And we can now use the overlap detection. I would recommend you simply setting it to the default distance, and now we will see how much data it selects. It actually selected quite a lot of like free floating parts we can simply delete. And I guess with this setting we can go to the meshing step. There would also be the possibility to smooth the model or to simplify the scan data or the point cloud data. Smoothing can be done if you have very rough surfaces, but it doesn't seem to be necessary here. And the simplification step, I normally don't perform on the point cloud at all. If I do simplification, we can later do it with the mesh itself. So as you can see, I go into the mesh, select the recommended setting of 0.22 millimeters. I use the high quality mesh setting. Actually, I haven't tried around with the fast meshing too much at all. Maybe I will have to play around with it. It is quite a lot faster, but I currently haven't used it a lot. I will specifically not using the hole filling because I want to keep like the actual gaps between these wooden strips. So let's now perform the meshing and have a quick look at the GPU at the usage. So currently at the CPU usage is climbing a bit, and you have like 20 gigabytes of RAM used. For the Revo software, it is actually quite conservative with the used resources. So I will run the meshing through, and then we will be back in a few minutes when it is finished. So the meshing finished after roughly 3 to 4 minutes, and it looks quite nice, I must say. Especially like it also captured all these small wires with the lighting quite good. You have to keep in mind the wires are like transparent plastic, so it's actually quite a nice scan. And I guess this will be my entry to the Revopoint Christmas competition. So we can now, we could theoretically simplify the model, but I will do this in Quicksurface. Now I am in Quicksurface 26, and I will open the scan I've just saved of the deer. It may take a few seconds, and you can see we're currently having 13 million triangles. So that's a bit much for a Sketchfab upload. Generally speaking, I must be under 4 million triangles to be under 100 megabytes for the PLY file. For this reason, I am now performing the prepare scan function of Quicksurface. This is quite a nice workflow to like reduce a scan, reduce like floating parts in the scan, and also perform the alignment. Now it is taking a few seconds to load the reduction. I will try to reduce it to 30, maybe even 25%. 25. Okay, this seems to be a bug in Quicksurface. I cannot like fully delete the one. So now let's try it like this. 29. It's okay. 29% should work. It now is reducing the mesh. For very large models, this can take a few seconds, but generally speaking, it is quite fast. You have to keep in mind, currently we have like 50 million points. I can also look at the deviation of the mesh. Like it's the deviation between the reduced and original mesh, and we're currently 99.994% of the points are within 0.03 millimeters, so that's fine for me. I will accept. Keep in mind, accepting means also losing the original model. So let's now isolate our main body by selecting it, click in one. So as you can see, currently I have 376 individual meshes. I will now make a run mesh out of it. And additional point you can do is removing duplicated triangles. So next step is creating a symmetry plane for the alignment. I will just do a very rough align with this. This is more like, keep in mind, this is more a natural body, and there will be not a lot of option, not a lot of detail in this kind of alignment. I will just use it for very bare or very rough alignment. Now I'm selecting 3 points here in the feed, which I will be using to create a plane. It looks like it selected the wrong data. So we select here on the top, then here on the top, and here on the top. So now this looks great. And I will need an additional plane here on the back feed, like this and this. And one additional point I will be doing is constraining the plane to be perpendicular to the previous plane, so it's easier to use it for alignment. The first plane you will also always be choosing is the plane defining the z-axis. The second plane is for the x-axis, and the third is for the z-axis. And as you can see, z is currently pointing downwards, so I will flip the axis and apply the setting. So as you can see, our mesh is now aligned to the coordinate system, and this is looking great. And generally speaking, the scan is looking quite fine for this kind of hard wooden wrapping, or how is it called in English? In German it would be like Flechtwerk.